To graph an inequality, we're first going to be looking at graphing equations, because inequalities are kind of extending this whole idea of graphing equations. Well, if we want to graph x plus y is less than or equal to 3, like it says here, I'm going to start off by graphing x plus y equals 3. And the general technique, I mean, there's different techniques you could use for graphing these. You could use the slope-intercept form, subtracting x from both sides, so we get y equals the opposite of x plus 3. What I actually like to use, if they're written in standard form, is I like to say, okay, if the x-coordinate is 0, then this resulting equation, if I kind of cross that off, then the resulting equation says y equals 3, which gives me the point 0, 3. The x-coordinate is 0, the y-coordinate is 3. Alternatively, if the y-coordinate is 0, that kind of goes away. We get x equals 3. So we end up with 3, 0. So either way, we would get an equation, a line that looks like this. Yeah, I can do better than that. It's snapping. Oh well, there we go. So that would be the line x plus y equals 3. Now, to figure out the inequality here, what I'm going to do is I'm going to look at what happens if we have x plus y equals something else. This says x plus y is less than or equal to 3, so let's look at what numbers x plus y is well, I guess these ones are greater than 3. Well, for x plus y equals 4, x plus y equals 5, and x plus y equals 6, these are all going to be similar, except we have 3 here. This is the first line we started with. X plus y equals 4 is going to be going through 4, 0, and 0, 4. X plus y equals 5 is going to be a little bit higher than that. And x plus y equals 6 is going to be a little bit higher than that even. So up here we end up with, this is 3, 4, 5, 6. If we went the other way and look to see what happens, if we look at x plus y equals 2, 1, or 0, I'll start off with x plus y equals 3 again. X plus y equals 2 would be something like this, x plus y equals 1 would be over here, and x plus y equals 0 would go right through the origin. Well, okay, well, it's not the most accurate graph, but the point here hopefully is still expressed. This would be a 3, a 2, a 1, and a 0. So you'll notice that all of all these lines where x plus y is less than or equal to 0, or x plus y is less than or equal to 3 rather, all of the lines where x plus y is less than or equal to 3 are over on this side of x plus y equals 3. They're lower and to the left. And so what we would do if we were graphing this is, well, we would go ahead and start off with x plus y equals 3. I'll talk about the script, or the writing that's here in just a second. And we would want to say that everything on this side of the line is also satisfies this inequality, because that's what, when we're talking about graphing something, we're trying to show all the points that satisfy the inequality. And so what we do is we just shade that side of the line. Alright, so on this one, if you're exactly equal to x plus y equals 3, it does satisfy this inequality because this is less than or equal to 3. But then there's the question, if this was x plus y is strictly less than or equal to 3, then what we would end up doing is we'd do something similar. I wonder if this does a dashed line. No, I don't think it does. But instead of doing a solid line, what we'd do is we'd do a dashed line at x plus y equals 3, and we would shade this side of the line. So the dashed line represents, it still represents a barrier between, over here we have solutions, values that we can plug into this equation to make it into a true statement, but the barrier itself is not part of the solution set here. If I plug in this point into this equation, I get 3 is less than 3, which is not a true statement. Similarly, points over here, I would get, something that adds up to 5, or maybe 6. Something that adds up to 6 is less than equal to 3, or less than 3. That's also not a true statement. That's why it's not shaded in. So in any case, the short of this is that when we have a non-strict inequality, either less than or equal to or greater than or equal to, we'll use a solid line. When we have a strict inequality, either less than or greater than, we use a dashed line.